Hello students, welcome to Preliminary Chemistry and the Water topic. This is video number 13 on dissolution and precipitation. In the next two videos we're going to have a look at how we know what's going on in solutions pretty much. You're going to have a look at a number of different precipitation reactions and try and identify the kinds of relative solubility of different salts in solution. But we want to just make sure that we've got a kind of a clear model that we can use to explain what's happening. So let's have a quick look here. Firstly, a solution is a mixture of ions and water molecules. So we know that a solution is basically a mixture of a solute in a solvent. Now what we've started to do is we've added multiple solutes. So they may be greater than one solute in a solvent. The ions move freely in the water as long as they are more attracted to the water molecules than they are to their oppositely charged ions. So we've represented our ions in the past as a nice little network, an ionic network, that is alternating between positive and negative. This is very poor and probably almost impossible to read, so let me add a few more over here. Plus, minus, plus, minus, plus, and minus, plus, minus. So these are all ionic bonds, and this is an anion, and this is a cation. And the reason that these would move away from one another is if, for example, a water molecule with its positive region attracted that negative ion there and was able to pull it away from the solid, from the crystal structure. If those bonds between the individual ions and the water molecules are strong enough, they will be pulled away from their adjacent ions and completely surrounded. And this is what a solution looks like effectively. When we have a solute dissolved in a solvent, then we have all of those ions completely surrounded by water molecules. Now, if we mix two solutions together, so we create two of these with two different solutes, put them all into the same container, then what we now have is effectively 4 ionic species. So that will be equivalent to 2 cations and 2 anions. Now, sometimes one or other of these might be common, but often it's 4 different types of ions. And we then look at what happens to the combinations when we put them together. Sometimes all 4 ionic species can coexist in solution and therefore remain soluble. This means no precipitate. However, sometimes a precipitate does form. And when the precipitate forms, it forms when the attraction between 2 oppositely charged ions is greater than the attraction between the individual ion and the water molecules. So it's possible, for example, to add something like lead nitrate to potassium iodide. Now when you do this, you have lead ions, which is a cation, nitrate ions, which are an anion, potassium ions, which again are a cation, and iodine ions, which again are an anion. So we have 2 species which are anions and 2 species which are cations. In this case, the attraction between the lead and the iodine is very strong. And so we form a compound lead iodide. It's very easy to see because it's a beautiful bright yellow color. The lead iodide comes out of the solution as a precipitate, as a solid that does not dissolve. And that's because the attraction between these 2 ions is so strong that it overcomes the attraction for the individual ions with surrounding water molecules. What this means is that a precipitate will only form, an insoluble solid that does not dissolve in the water will only form when these oppositely charged ions bond ionically to each other and as a consequence come out of the solution. How do we know this? Well, we've used radioactive traces to start to help us track what's happening to ions in solution. So we can put some radioactive lead into a solution which will have a slightly different mass number. Usually the only difference in radioactive isotopes is that they are the exact same element, but they have a different number of neutrons in the nucleus. And if we have a radioactive form, then we can start to track what's happening as the lead ions, oops, let's turn that from that to that, as the lead ions in the solution mix around with potassium ions, nitrate ions, iodine ions, and so on. And what we can see is that these little radioactive traces will actually start to form with the cations as they precipitate out. Now, what's interesting is that if we use this idea of radioactive traces to see what's happening when we saturate a solution, then some very interesting things happen. But we're going to have a look at those in the next video. Thanks for watching.